Hello, and welcome to the So You Want to Be a Marine Biologist podcast, where we learn about the ocean, share sea stories, and explore ocean careers. I'm your host, Kara Muzia. Let's dive into today's episode. This episode is brought to you by you. Thank you to those of you who have become patrons of the So You Want to Be a Marine Biologist podcast. For less than the cost of a dive tank refill, or a cup of coffee, you can help keep the podcast episodes coming. There's also some fun bonuses for patrons, so be sure to check those out at patreon.com/marinebio.life. That's patreon.com/marinebio.life. Hello, mermaids, pirates, ocean lovers, and land lubbers. Welcome to today's show. Question: why did the fish blush? Because it saw the boat's bottom. Why should you never fight an octopus? Because they're too well armed. My guest today is Emma G., a legal fishing and transparency analyst for Oceana. I've been wanting to have someone on the show to talk about IUU fishing, or illegal, unreported, unregulated fishing, and it's also known as pirate fishing, and I'm really excited to have Emma on to chat more about it. We break down what IUU really means, how we can learn what the ocean looks like way before recorded history began, and what shifting baselines means for our oceans. Emma also has a great conservation ask, so stay tuned to the end for that. Please enjoy. Emma, welcome to the So You Want to Be a Marine Biologist podcast. I am excited to chat with you today.
Yeah, thank you so much for having me. I'm excited to talk also.
Awesome. So before we get into fishing and fishing fleets, I want to chat about your story. You knew you wanted to be a marine scientist, it seems like, when you went into college, but instead of studying biology, which a lot of people lean towards, you have a degree, an undergrad degree in environmental systems engineering, and then a master's in earth systems. So what prompted that?
Yeah, so I have kind of always known from a young age that I wanted to do something environmental. That's kind of just always what my brain has been thinking about. Like, I remember being like maybe 7 years old and holding a garden hose and thinking, what would happen if we ran out of fresh water? So that's kind of the way that my brain has always been oriented. That's the stuff that I've always cared about the most.
Mm-hmm.
And so I went into college knowing that. I originally planned to do chemical engineering as an undergrad degree, but that degree at the university that I went to is fairly inflexible. You are very much held to that specific curriculum that they have. I wouldn't have been able to explore kind of other applications of what I wanted to do within that degree, especially the environmental applications. So I started looking at what else I could do. And I had not really initially wanted to do marine biology coming into college.
Mm-hmm.
I think I kind of took some classes freshman year in a variety of different environmental areas, and oceans was just like the thing that held my attention the most. We went to Monterey, like we went whale watching and tide pooling, and I saw all these incredible things that live in the ocean. It was just such an incredible system to see. And so kind of from there on was my diversion towards marine biology, towards ocean science, but I have always been very math oriented and computation oriented.
Mm-hmm.
So I wanted to do a degree that would help me build up these technical skills that I really enjoyed, while also exploring ocean science from a more conceptual side, which is how I ended up with environmental systems engineering, because it was a newer degree at the time, and there was a lot of flexibility for me to take computer science classes on the side while also doing like biological oceanography and fulfilling all these different requirements for the major. So I think that there is a lot of value in an engineering degree just from learning about how to approach problems, building up these technical skills to kind of be able to approach any sort of problem that you want in the future.
Mm-hmm.
And then I could also build that more conceptual understanding of ocean science at the same time. So that is why I chose that degree, with the idea in mind that later on I could specialize a little bit more in marine biology or ocean science,
Mm-hmm.
which is more of what I did in my master's program. my university has a thing where you can apply for a master's program and you can count some of the classes that you took as an undergrad towards that master's. And that was a really good deal for me because you build these relationships with professors while you're an undergrad, and then you can use those to get TA-ships and get your master's paid for that way. So it's a little
Hmm.
bit less stressful to figure it out. You get your master's done in a shorter amount of time, which I hadn't realized this at the time, but most people, at least in the field where I work, have at least a master's degree. So it's really useful for me to just get that out early, get it out cheaply, to be able to kind of meet what the standard is for what people are looking for jobs in my field.
Did you know going into school that you wanted to get your master's, or was this something you kind of like figured out while you were doing undergrad or like looking for jobs later?
Yeah, it was something that I figured out while I was doing my undergrad. I looked at programs like in other schools as well for master's programs, and it just seemed kind of the most efficient route to continue at my same university, again, because it was just easier for me to get TA-ships and get the tuition covered. And I think that there were also like some knowledge gaps from undergrad that I wanted to cover. Like there was more kind of in the higher levels of computer science that I wanted to explore. And also, I wanted to explore more of kind of the interdisciplinary nature of ocean science. And so the program that I chose was a very interdisciplinary program, the Earth Systems program. And so I was able to look at some of these interdisciplinary concerns with ocean science. And I can also take things like deep learning or machine learning with graphs. So I could continue to explore the technical aspect while also building out, again, that conceptual understanding. And I think that's kind of a lot of, at least for my friends, why they chose to do a master's, is because they realized there were these like technical skills that they needed for the professional world, that they hadn't really gotten in undergrad. So it's just filling in those gaps.
Okay, that makes sense. So, for your master's, you had a really interesting thesis studying long term trends in shark abundance in the Indian Ocean. Could you explain a little bit more about what your thesis was and kind of how you went about analyzing it and collecting data for it?
hmm Yeah, so I had a professor from undergrad who was super awesome. Barbara Block was, she just like has all of these really interesting ways of approaching problems. And so I knew that I wanted to do a thesis in her lab. So I approached her and asked her about kind of what projects were going on in her lab. And she had a postdoc named Francesco Ferretti who does a lot of historical ecology. So historical ecology is kind of looking at trying to reconstruct the way that populations have been in the past, because
Mhm.
humans have been influencing oceans on a very large scale for a very long time. But we have not really been able to observe the effects of these changes until very recently. We also haven't really had the motivation to do that until recently. So it's caused these problems with, under current management regimes, we can kind of manage what we observe now, but we don't really have context for what we should be aiming for in terms of what these populations were like in the past. So if we've been fishing tuna since the 1960s on a large scale, but we are only taking into account the last 20 years of tuna populations for management, maybe tuna populations are really unhealthy now compared to what they were 60 years ago. And
Right.
we're managing it under this false assumption that we're doing okay because they're stable, but maybe that stability is kind of at a lower state than what it used to be.
Right. The baseline shifted.
Yes, yes, that's the term that marine biologists like to use, is the shifting baselines.
Yep.
A lot of what this thesis was trying to do was to reestablish these baselines, especially for sharks. Sharks are caught very often in industrial fishing processes. So we were specifically looking at long lines, which are these very, very long lines of hooks. They have thousands of hooks. I think like the average long line in the US fishery is like 34 miles long. So it's thousands and thousands of hooks that are just kind of being chucked out into the ocean. The fishers are leaving them there for a certain amount of time, and then they come back and they pick them up. And they have pretty high bycatch rates, so they're catching a lot of species that are not intended to be caught. So
Mhm.
these longliners are primarily aiming to catch tuna and swordfish, but they're also catching a lot of sharks in the process.
Right.
So these sharks often get discarded, or later on, and starting in the 1980s, is when shark finning really started to pick up. So
Mhm.
fleets started to target sharks more, and then when they accidentally caught them, they would just cut off the fins and throw the shark back because the fins are pretty small, so you can just store those on the ship, but the rest of the body of the shark is not really meant to be eaten because I guess sharks don't really taste that good. So we were looking at how all of these trends in catch and shark catch have affected populations of sharks. So we wanted to see both how the abundance of sharks has changed from the 1960s to present day, and then also how the community has changed, because that's not really something that's been done before. We had a historical survey that was conducted by the Soviet Union from the 1960s through the 1980s. What they were doing is they were trying to figure out where the most biologically productive spots were for longlining so that they could kind of direct their fisheries to go to those spots that they found. They were also recording the sharks that they caught at very high species resolution, which is often not the case. It's still not really the case in industrial fisheries. A lot of industrial fisheries, they have like the main 4 species that they catch, and they'll say, oh, it's one of these species, or it's just this general category of other sharks. But there are a lot of shark species. I think there's around 200 or 300 in the world.
Right.
And a lot of them are very hard to distinguish from each other. Like there's a lot of species in the genus Carcharinus that look very similar. It's kind of like the stereotypical shark, like kind of gray and has fins. But they were actually identifying them to the species level, which is really valuable information because even now we don't really have a lot of catch information for these species that are outside of that main like group of blue sharks, silky sharks, oceanic white tips, makos. So anything outside of that group, we don't have a lot of information on. We have all this data of we caught this many sharks of this species in this location, we caught this many species in this location, but that still doesn't really give you a good idea of what the abundance is because there are a lot of factors that affect whether or not you're going to catch a shark. So there's the kind of gear you're using, there's whether or not you're in the right place at the right time because sharks migrate. So maybe you caught a lot of sharks because the sharks happened to be migrating through the area at that time. And that doesn't necessarily mean that there were a lot of sharks in the ocean as a whole. It just means that there happened to be a lot where you were. So there are all these effects that you have to normalize out to get any sort of idea of what the true abundance is. We were using statistical models to try to normalize out these effects and get an idea over time of what the abundances were of these sharks and how they were changing. A common indicator in fisheries is the standardized catch per unit effort, the number of sharks you caught per 1,000 hooks that you were putting out. We were trying to develop these indices for all these different species that were caught in the USSR survey. So that gives us information from the 1960s through the 1980s, which is kind of that initial period of industrial fishing. So kind of we assume conditions are near pristine in the 1960s because there were only 2 fleets fishing in the Indian Ocean in the 1960s, and then through the 1980s. And then past that, we used information from a regional fisheries management organization. This is a part of the FAO, the Food and Agriculture Organization, and it's an international body. There's lots of different member states that are a part of it. And they are in charge of managing the tuna and swordfish populations pretty much in the whole Indian Ocean. But they also are supposed to be keeping track of the bycatch species like sharks. They have information more towards the present day on shark catches. It's mostly from the 1990s through the 2010s because a lot of the fleets that are part of the IOTC, fleets that are part of the Indian Ocean Tuna Commission are recording the number of sharks they're catching. It's often just the number of sharks. It's not really broken down by species. So there aren't that many species that are actually being recorded by these fleets. So it's just a couple species where we can actually make these long-term trends from the 1960s through the 2010s of how the trend has changed overall through that entire 60-year period. That was the main motivation of why we started that project. Since then, I've kind of been working on that since graduating, so that was like my thesis focus, and we're now working on getting it published.
Okay.
For that, we're trying to introduce a more novel aspect of our research, and that is looking at how species have changed relative to each other. Because there have been a lot of papers that have said sharks are declining by 70%. There's been a crash in shark populations. So that's not really a new insight, even though it is really useful for a specific region to be able to give them what specific species are doing. That's really useful for their management. But in terms of kind of the overall body of science around sharks, that's not really a huge insight. And so we've been looking at how sharks change relative to each other, trying to figure out if more generalistic species were able to thrive because they are able to avoid areas where there's lots of fishing and kind of retreat to a different habitat instead, whereas species that are kind of more dependent on the open ocean and can't really go towards the coast have been more impacted by fisheries and kind of what the ecological implications of that are. That's where that project currently stands. Yeah, that was my thesis.
Yeah, that's an amazing thesis. What are you finding right now as far as like how are we standing historically from the 1960s to now? Are you showing that there is a 70% reduction? Like, have been papers published worldwide about this? And are there species that are doing well comparative to others?
Yeah, it was. I was really surprised by the results from the USSR survey, so from the 1960s through the 1980s,
Mm-hmm.
because there were species that immediately declined because of fishing, but there were also species that happened to increase over that same time period. So I think from the species identified in the survey, there were 5 that initially increased over that time period,
Mm-hmm.
and we think it was probably from ecological effects, so they were maybe released from predation or released from competition with other sharks, because there are larger sharks that, like hammerheads, that will eat smaller sharks, like juveniles.
Right.
So if you have a species that uses the coast as a nursery, so they have their young grow up there, and you have species like hammerheads that are coming through and sometimes eating these younger species, if you remove the hammerheads, then you are helping these younger individuals of these species survive at a higher rate, and so you might expect that population to increase, at least in the short term. So I was really surprised by that variety in the responses initially, because I think like these estimates of these huge declines in shark species often don't have very good temporal resolution. Sometimes you're comparing a data set like from the 1960s to a data set from the 2000s. So you
Mm-hmm.
see like in the long term, there's a decline, but you can't really see kind of what happened in between. So I think that's kind of what was novel about our project, was you can see more what the varied responses were and more of what the ecological effects were. Because those ecological effects do get worn down over time. If you're continuously fishing these sharks at a very high rate, eventually you're going to destroy whatever advantage certain species had over other species, and they're all going to decline. But if you can look initially when fishing pressure wasn't that low, you can kind of see who had advantages and who didn't over that time period.
Yes, that's fascinating stuff. The historical ecology, it kind of just goes back as far as like our written records, or is there somebody that tries, or are there studies that try to go back even further and imagine what it was like before we even started getting on the ocean and collecting fish?
Oh, yeah. I mean, historical ecology is super cool. It's kind of like detective work. You can use all of these different indicators, some of which are from people, some of which are more from what you can see in like sediment cores or something like that. So I know that there are projects that are looking at denticles. Denticles, I think, are like made of similar materials to what our fingernails are made of.
Mm-hmm.
And it's what shark skin is made of. It's why shark skin is so rough, contrary
Mm-hmm.
to the memes.
Yep.
And so these denticles can get left behind in sediment. And so you can look for them in sediment cores and kind of try to see what the composition of species were at that time. So there are kind of like, I guess maybe like archaeological ways that you can do historical ecology. There's also like all these really cool ways that you can try to look at what abundances of species were like in the human record. So I mentioned my main advisor, Francesco. He has done research trying to see what the abundance of great white sharks were in the past based on shark attack records. So using
Okay.
that as a proxy for how many sharks were in the area. And again, you have to normalize for like what the population is on the coast, how many people would be in the water to potentially be attacked. So there's a lot of kind of complicated statistics that go into using that kind of data. In Japan, there's the art of fish printing. So they'll take a fish that they've caught and like cover it in ink and print it on the piece of paper.
Okay.
And there are libraries of these prints of fish, and you can go look at them. And you might see maybe a species might have been more common in the past because there are a lot of prints of them from the past. So there's lots of kind of different ways that you can find these pieces of information and pull them together.
Okay. But this is quantitative. So for you and your studies, is there any like measurements? Are you seeing a decrease in size or an increase in size for certain species, or is that data not collected usually?
Yeah, no, we were lucky enough that the survey also collected size, and that is something that the IOTC collects also, is the sizes of sharks that are caught. So we were able to look at how the sizes changed over the USSR survey and then also compare to what the sizes are now. And we do find that species are smaller on the whole, like the individuals within a given species are smaller than they were 60 years ago, which is what you would expect. You can't really have fishing without having some sort of effect on the sizes of individuals in a population.
Mm-hmm.
That's kind of a supplementary piece of information that shows that the changes we see are a result of fishing because we see that very direct effect on the sizes of the species.
Okay. Hey, Kara here. I hear it all the time. How do I become a marine biologist? Or my niece wants to help the ocean. Where does she even start? I hear from students, yes, and also nurses, HR professionals, and other mid career folks who wonder if they could still make their dream of working with sea turtles or sharks come true, wondering if it's too late to answer the ocean's call. Here's what I've learned after 20 years in the field and hundreds of interviews. There's no straight line, no magic degree, and no gatekeeper. You create the path forward. If this sounds overwhelming and vague, I've created 2 tools to help you stop wondering what if and start moving forward with clarity and purpose. The first is my free guide, Be a Marine Biologist Without the Degree. Over 1,000 people have already downloaded this guide and taken their first step towards ocean impact. Inside, you'll find 7 concrete, doable actions to help you get started, whether you're just exploring or ready to make a change. Then there's the Ocean Blueprint. This is a 30-day self-paced course that helps you build your unique path into ocean science and conservation without quitting your job or going back to school. Inside the Ocean Blueprint, you'll get daily prompts to explore your interests, skills, and next steps, a structure that turns overwhelm into real momentum, and a bonus section to root your work into ocean connection. You don't have to wait for a degree, a perfect plan, or permission. Whether you're wading in or ready to take the deep dive, these tools are here to help you move from dreaming to doing. The ocean called. Are you ready to answer? Links in the show notes and on my website, karagracemuzia.com. I can't wait to see the waves you'll make. When you were doing your analysis and writing your thesis, and even now, you're not in the field collecting the data, right? Like you mentioned the USSR study, you're looking at other people's records from actually fishing there. Is that correct?
Mm-hmm. Yeah, that is kind of the curse of doing historical ecology data, is you don't really get to collect your own data. It's kind of blessing and a curse because you don't have to deal with that, and especially like with COVID and all these different travel restrictions, my research has not really been affected at all by the recent pandemic.
Right.
You still get to collaborate with other people in other fields. So we work a lot with people from the Indian Ocean Tuna Commission to kind of contextualize the research that we've been doing and try to incorporate that into management.
I love it. But you have gotten in the field. You do like to dive and be out in the ocean. And during, it seemed like your undergrad and maybe your master's program as well, you did Stanford at Sea. So you got to spend some time on the ocean.
Mm-hmm.
Tell a little bit about what that program is and what you got to do.
Yeah, Stanford at Sea is a really great program. It's an offshoot of Woods Hole's SEA program, so the Sea Education Association.
Mm-hmm.
My advisor, Barbara Block, this is actually how I got to my thesis, so we're kind of coming around. Yes, my master's thesis advisor, Barbara Block, is the one who runs Stanford at Sea. She did Woods Hole's SEA program as an undergrad herself, and that kind of like totally changed the trajectory of her life, which is why she was so passionate about bringing it to Stanford specifically.
Mm.
So if you do Woods Hole's SEA program, the format is very similar. It's just that you get mixed in with other people from other universities. It's kind of like a study abroad program that anyone can apply to. At Stanford specifically, it's for Stanford students who apply to it. And then the format of the program is it's 5 weeks at Stanford's Hopkins Marine Station in Monterey. So you're taking classes on navigation and oceanography and the history of the islands that you'll be going to. And then you spend 5 weeks sailing on a tall ship through a specific track. You are standing watch, you're responsible for helping to put up the sails, take them down, do the navigation, and you're also conducting a project. So you can either do an oceanography project because the ship does deployments twice a day. So we put down a hydrocast, which is this big thing with a lot of tubes, and the tubes are programmed to close at certain depths. So you
Mm-hmm.
get samples of water from certain depths in the water column. And
Mm-hmm.
you can look at things like the nitrogen concentration, phosphorus concentration, dissolved oxygen. And then you can also do potentially a coral reef science project, which is what I did as a student. I looked at giant clams because we were in the Pacific Ocean
Mm-hmm.
and whether they were bleaching in the same areas as corals because we went in the spring of 2017. So we wanted to see if following this mass bleaching event that happened in 2016, if clams and corals were bleaching in similar areas because giant clams actually have some of the same microalgae that live in their tissues as corals do that help them to photosynthesize.
Right. Which gives them their pretty colors. We've talked about giant clams on the show before, and a lot of my audience was like, wait, they're not just like gray little things. No, they're like 4, 5, 6 foot huge clams that can be purple and teal and just amazing.
Yeah, they're really incredible animals. I saw them in Australia, which was how I came to this project because I was like, wow, these animals are just incredible. They're beautiful. They're so interesting. I think, like you said in the podcast, like there's not been a lot of research on them and their bleaching.
Mm-hmm.
So I was interested in looking at that correlation.
Mm-hmm.
Yeah, so I think Stanford at Sea is a really incredible opportunity, or sea in general is a really incredible opportunity to get out into the ocean. I think a lot of what I'm interested in now has been a result of that because it really gives you an appreciation for the open ocean and how vast and beautiful it is. And I think like there are not a lot of other ways that you can get exposed to something like that. So if you're in college, I would encourage you to apply to SEA. I think they're still running programs now.
Yeah.
I think mostly in US waters. But yeah. So I did that as an undergrad and then just like couldn't get enough of it, had to come back. So I went and TA'd it as a master's student. So I was kind of helping the students oversee their projects, helping them order their materials, design their projects, and just helping with the overall functioning of the boat. So yeah.
Love it. Awesome. Sounds like such a cool experience. Yeah, there's Woods Hole has their sea program. I hadn't heard of Stanford at Sea until I saw that you had done it. And then I know there's Seamester, which I have friends that have one captained the boat and one was teaching on it. So there's a few options for listeners if you want to get out on a tall ship and get on the ocean. Definitely some options. Very cool. When you graduated, did you immediately start working for Oceana?
Yes, yeah. Oceana is my first job out of graduating. I was a fellow there for a year and I'm now working as an analyst full time.
So what does a fellow mean? You're an intern?
I'm not sure why Oceana has it set up this way, but we do have like 1 year fellowships for illegal fishing and transparency, but you get all the same benefits as a full-time employee. It's just that you have a set end date.
Okay. So it's like we're hiring you and we're going to try each other out. And if it works, we'll continue. And if not, then that was a nice year.
Yeah, I think so. We do also have a lot of internships. I think like most of the ways that people enter Oceana is through internships, which
Mm-hmm.
are paid. But I think like for what I do specifically, it's so specialized and there's so much technical skill that goes into it. I guess the fellowship is like a little bit of a step up
Yeah,
from the internship.
That makes sense because what you do is super technical, and I'm excited to chat with you about it. So you track illegal, unreported, and unregulated fishing vessels in the open ocean. How do you do this?
Yes. So we use a tool called Global Fishing Watch, which is also their own NGO that was formed in part because of Oceania. What they do is they use something called AIS data. AIS stands for Automatic Identification System, and it's a safety at sea tool. And basically, when a boat is out fishing, or really any sort of larger vessel, like a cargo vessel or passenger vessel, they are pinging out their location between every couple of seconds and every couple of minutes. And the system was designed to help boats avoid hitting each other. You ping out your location, you can also see where the other vessels are, you can see where they're headed, how fast they're going, that kind of thing, so it helps you avoid hitting the other vessels. You also have receivers either on land or from satellites that are also receiving these position messages. And these are run by a variety of different companies. And Global Fishing Watch has contracts with two of these companies to receive their data. And they apply machine learning and all these different algorithms to it to figure out what the boats are doing based on the way that they're moving. They employ technology called a neural network to figure out, I think the initial vision was to figure out when boats are fishing and when they're not, because they move in these very characteristic patterns when they're fishing. Trawlers move back and forth a lot when they're fishing. Longliners tend to move in circles. Same with purse seiners. So a trawler is a vessel that has this net behind it, and it's basically just like dragging the net behind it. So if you think about kind of doing that, the vessel kind of has to move in a straight line, and then maybe it'll turn around and do that again. And longliners I've talked about, and purse seiners have these nets that they put in the water, and they circle the net around whatever species they're trying to catch, and then they cinch that net and they pull it up. So you can imagine, like, these vessels have to move in these very specific ways. They have to move at very low speeds. They're often changing direction a lot. So you can develop algorithms to identify when they are doing this behavior and also identify what kind of gear they're most likely using. Global Fishing Watch also looks at a lot of different registries around the world, and they'll look at what kind of gears these boats are registered to be using, and from that also infer what kind of fishing they're likely doing. They take all this information together and they look at whether the vessel is fishing in any given area and whether they're not. We can also look at potentially if their AIS signal is lost, if they've potentially disabled their AIS, or they're in an area of very poor reception because there aren't a lot of satellites. We can look at loss in the track of the vessel. And we can also look at whether vessels are meeting up with one another. We can see if their AIS signals are converging and they happen to be traveling together at a very low speed for a certain amount of time. That would indicate that the vessels are potentially transshipping. Transshipment is basically they're exchanging something between the vessels. They can be exchanging catch, they can be exchanging crew. If one vessel doesn't want to come to port for whatever reason, another vessel could be giving them fuel. So we can look at all of these different behaviors of vessels based on how they're moving, which is kind of the bread and butter of what we do.
Yeah, it's important to kind of monitor this because illegal, unreported, and unregulated fishing, I saw a statistic. This comprises like 1 in 5 seafood catches in the world. And illegal meaning that boats are fishing where they shouldn't be, or they're in a country that they shouldn't be in. Unreported means that they're just like collecting fish that they don't tell the government about. And then unregulated, they're fishing in waters that are actually not regulated. Like they don't have the monitoring that like some of the studies that you've seen and researched, they don't have that monitoring. So there's just not that set data set to actually pull fish from. Am I missing anything with explaining IUU?
Yeah, that's a pretty comprehensive definition. I think like the unregulated also, there are just very large portions of the ocean that are just not managed by any given body, or there are a lot of species that aren't managed. So a lot of squid, for example, comes from areas that there's no one saying how many squid any person should catch, and so that's part of unregulated fishing as well.
Okay. So they could catch all the squid and nobody would be able to say anything about it.
Yep. There's no like international recourse for that kind of thing.
Okay, so this is high seas, no jurisdiction, and this is also, in the country's exclusive economic zones, which we chatted about on my last episode. This is the area, it's like 200 miles offshore from any given country. They have control over. They can say who comes in and what fish they can monitor and regulate. You're talking about AIS. I have a friend, as like a fun insert here. I have a friend that just really loves big yachts, and there's apps that track them, and they use AIS. So he just is constantly like, "Oh, this yacht's by you. Oh no, now it's up by me. Oh, now it's over here in the world." So for fun, anybody can use the AIS programs and just see where fun boats are.
Yeah.
But this is what you do on a daily basis. So what are some of the things you mentioned, like you look for these specific patterns? Do you have like specific areas of the ocean that you monitor? Do you have alerts set up? Like what, I mean, the oceans are enormous. Like it seems, and there's so many people and so many boats out there fishing. Like it seems like a very huge task to actually look and be like, oh, this person's starting to move in this certain like part of a pattern. Do you have specific boats that you are looking for, or specific regions of the ocean that you're particularly honing in on?
Yeah, Oceania has a variety of offices in different countries, and
Right.
we have employees who are like citizens of those countries. They work very closely with fishermen in those areas, with policymakers in those countries, and they will sometimes get fishermen saying like, "Oh, we've been seeing a lot of kind of foreign vessels like off on the horizon. We don't know what's happening, so
Mm,
we'll look into that." Or there will be instances of kind of anecdotal things like a lot of people are fishing right on the border of Argentina's EEZ. They're turning off their AIS, but you can't really take action based on just kind of that anecdote.
mm,
And so what we will do is actually come in and quantify and make concrete what is happening. And
mm.
that can give policymakers and advocates more ammunition that they can use to advocate for change. So, for example, there was last year a lot of Chinese vessels fishing around the EEZ of the Galapagos Islands,
Right.
and that is something that has been happening for a while. People can like say that it's been happening, but you can't really draft any sort of legislation based on that. We went in and actually looked like how many vessels are doing this, how many hours of fishing are happening, how close are they getting to the EEZ, and that actually gives you something concrete that you can use to advocate. That's a lot of how we come up with the ideas for the kind of analysis we do. We also kind of will look at Global Fishing Watch has a great public facing map that you can look at. You can explore, you can look at EEZs, you can look at MPAs, you can look at what is happening all over the world very quickly. The map works super well. You can click on it and then look at what a specific vessel is doing. So we also kind of just do some general scoping using that of seeing what's going on and what might be interesting.
Okay. So really it takes a tip off. It's not like you guys are like monitoring specific areas. Like you start to hear rumblings from concerned citizens or maybe concerned fishermen, right? That are like, hey, I'm observing this vessel. It's coming in, like it shouldn't be in here, or it's turning on. I see it. It's on the map and it's not on the map. Can you guys look into this? Then you go in and do your analysis and you're able to provide the data of like, yes, it's coming in close to this EEZ and then it's turning off its AIS, going in, doing, and then few days later it comes back out, right? So then what can you do with that data?
Yeah, so I will say we do look at specific areas. So some of our country offices, we have kind of ongoing alerts that we send them. For example, for our Peru office, we will send them vessels that are coming into their major ports and tell them what they've been doing for the past 30 days to
Okay.
help them prioritize who needs to be inspected coming into those ports. So I guess that's also, that goes into your question that you just asked. Yeah, so some of it is like there's so much going on in the ocean, as you said, and it's impossible to know what everyone is doing all the time,
Right.
at least from kind of a regulatory standpoint. So some of what we do is helping prioritize who needs to be taken a closer look at, helping different government agencies kind of quantify what's going on and get a better idea of whether a regulation needs to be changed. So if vessels are not complying with a specific restriction, letting the government know that so they can start to kind of think about whether they need to reevaluate how that area gets enforced and what the legislation around that is.
Okay. Yeah, that makes sense. It's kind of like a twofold. Like one, it's almost instantaneous action. Like, hey, these are the these are the boats we've been monitoring, like you mentioned Peru. So these are the boats that we've been monitoring the last 30 days. This one's kind of been a little bit off. You might want to check this one first, and they can go in and start to analyze their catch and like make some decisions that way. And then, or you can be like, we've observed these things, and it can be pushed down the line for further regulation. And it does seem like your report and then the inspection report, like actually somebody physically getting on the boat and seeing what they caught, would go hand in hand really nicely to inform legislation, is how I want to put that.
Yeah, both legislation and kind of enforcement. And we don't solely do fishing. We also do kind of other vessel behaviors. So the whole east coast of the US has areas where there are basically speed restriction zones for speed limits for boats that are coming in, and that's to protect the North Atlantic right whale, which does get hit by ships. And so we look at whether vessels are actually complying with those speed limits. And then we can point that out to NOAA and say vessels are not complying with these speed limits. There are these areas where North Atlantic right whales congregate that are not subject to these speed limits, where vessels are traveling very quickly, and advocate for change there as well.
Okay. Can we send a police officer out and give them a ticket? They get on a copter and go out and give them tickets.
I think there is the Coast Guard, but again, it's such a large area that it's really difficult
Right.
to, yeah.
Can they be fined though? Like you have the data, right? Like, hey, I see you were going this fast through this area. This is protected. You're only supposed to be going this fast, so therefore you get a fine, or is that not? That doesn't happen right now.
I don't know of any fines that have occurred as a result of a vessel breaking a speed limit. I think another part of the issue is a lot of these vessels are flagged to foreign countries or countries that have very lax restrictions. So they have something called a flag of convenience, which basically means they have paid a country like Panama to be able to use their flag, because
Right.
Panama is not party to a lot of different international conventions and laws. So therefore, because they fly Panama's flag, they also don't have to respect those laws. And so if the US were to want to fine a vessel from a country like Panama, there's this whole web they would have to go through to actually figure out who would need to pay that fine.
Gotcha. Okay. Yeah. Because Panama doesn't have a seat at the table. They're like, well, you're fine. I don't know what to do with this. So it doesn't. Okay.
Yes, there's that, and then there's always these questions of who actually owns the boat and who is responsible for the actions that the boat does.
Right.
There are these huge webs of shell corporations, often in other ways, that obfuscate, obscure who actually owns this boat, who is benefiting from what it does. So it's very confusing often when there are like labor disputes or the boat is doing something illegal, who needs to be held responsible for that action, because it's often not clear who actually owns the boat, in addition to where it should be flagged to.
Right. And that's something I've learning more recently, is that it's not just the IUU fishing that is impacted by these large ships. There's also labor issues. Like marine pollution is related to these big boats. There's just some sketchy things that happen on these boats are from these like shell corporations, like you were mentioning, that can't pinpoint an owner for really not great, unscrupulous reasons.
Yeah, the illegal activities kind of unrelated to fishing and the fishing are very much related to each other often, because especially with things like labor, if you have a situation where a stock is being overfished, it's much harder to find that species now. You have to go out further. Fuel is very, very expensive for these boats. So if you're having a lot more cost from fuel, these boats are then having to try to figure out a way to cut down cost in other ways to make up for that. And oftentimes, what they cut down on is labor cost, which can lead to things like forced labor and slavery at sea.
Yeah.
Yeah, so they're very linked together, these issues.
Yeah. It just like brings it all home for me that like it's all related, like all like the ocean, the fate of our oceans and like our economic woes and like socio statuses are just, it's all very linked, and this like crystallizes that really nicely. I mean, not in a pretty way, but it does crystallize it. Wow. Okay. So you monitor. So where some of the other places that you monitor, you do the entire United States because you're based in the United States, or is it kind of broken up because that's a lot of country to monitor?
Yeah, it's a little broken up. We have separate people who kind of work on Alaska fisheries and the habitats there,
Okay.
and like California coast fisheries. So
Hmm.
they're handling a lot of like the local policies and politics for those areas. So because our team is based in Washington, D.C., we do tend to work a lot more on the East Coast. We have looked at things like trawling in Alaska because there's a lot of seamount habitat, like these deep sea corals, which are super cool. They filter feed like corals in a coral reef kind of near the surface do, but they don't really photosynthesize. They can live for thousands of years. They provide habitat, much like conventional coral reefs do for a lot of different species, but they can be destroyed by trawling. As I mentioned, there are these boats that are like towing these nets behind them,
Right.
and these nets can weigh like tens of thousands of pounds. They're weighed down by these huge metal doors, and they sometimes are scraping along the bottom of the seafloor, and they're just destroying everything in their path.
Right.
So that's kind of an issue that our Alaska office is working on, is trying to advocate for protection of these very vulnerable and delicate habitats. So that is something that we have helped them, again, kind of make concrete how much actual trawling is happening in these areas and how much of the trawling overlaps with the habitat of these corals, so we can look and prioritize what areas need to be protected the most from trawling, and again try to find like a balance between people still being able to conduct their livelihoods but also optimizing for ecosystem health. So that is another project that we've been working on. When I mentioned Argentina, we did a project looking at vessels that were turning off their AIS systems around Argentina. We did find that it was mostly Chinese vessels that were doing that, but it's also just because there are a large number of Chinese vessels in that area for fishing for squid, because squid is a very popular seafood in Asia. But we also found that there were 20 fishing boats from Spain there, and those boats were turning off their AIS at a rate like 5 times higher than everyone else. It's kind of cool sometimes to look at what the prevailing narrative is and then kind of drill down into that and see, yes, China is behaving badly, but it's also a matter of scale. They have a very large fishing fleet, they have a lot of people to feed. Seafood is very valued in China. And then there are also these boats that are kind of on a smaller scale behaving even worse than the Chinese vessels are. So that was a cool analysis that we did recently as well.
Yeah, it's interesting to look further into the narrative, because you always hear, Asians have a lot of seafood in their culture, and you have the Asian markets that are always like overflowing with seafood, and so everybody like paints them as bad guy. But then here's Spain over here turning off their AIS even more.
Mm-hmm.
It's cool, not cool. Cool to look at it, but not great that it's happening, right?
Mm-hmm. Yeah, exactly.
Okay. One of my questions that I like to ask on the podcast is, if you were to be given a blank check for any research, any project that you wanted, what would you use the money for?
Ooh, that is a really good question.
And it doesn't necessarily have to be research, just any project.
Mm-hmm. I think like one of the things that I am really interested in is these billfish in the Indian Ocean, because
Mm-hmm.
they're also kind of going back to my master's thesis, there are these fish like the black marlin that are kind of caught artisanally. They contribute to like sport fish economies in different countries, like ecotourism, and they're just like no one knows really anything about what their populations are doing in the Indian Ocean. No one really knows like what the effects have been from these fleets that are coming in, like from Spain and other European countries and very industrialized countries that are coming in and don't really have a stake really in what is going on in the Indian Ocean because they don't border it, and the kind of damage that they're doing ecologically from doing things like long lining, where they're catching a lot of top predators, including marlin, from these ecosystems. So I think that is something that I would be really interested in looking at. There's so much about these highly migratory species that we still don't really know. We don't know if it's all one population or if it's several, and what the effects have been from this kind of large scale industrial fishing from these countries. So I think that is something that I would be super interested in.
I like it. Okay. And you spent some time on the ocean, not just at your semester at sea program or your Stanford at Sea program, but also you like to dive and you're doing some incredible research. So what's one of your favorite field story or stories to tell? And this could just be like an amazing day on the water, or it could be a day where things happened and it makes a really great story now.
Yeah. Well, I think kind of going back to Stanford at Sea, the year that I TA'd it in 2019, we were on the boat with Barb. Barb wanted to see if there were sharks around this seamount that we were going to be near.
Mm-hmm.
So we put out some BRUVs, which are baited remote underwater video devices. So it's basically like a camera and you have a bait bag. And hopefully things will swim up to the bait bag and you will catch them on camera and kind of see what they're doing. So we put those together. We threw them over the boat to see if we could catch anything. But in the meantime, we started chumming the water a little bit. And there was this shark that kind of started to emerge from the murky blackness because it was at night. And people were like, oh my God, like what kind of shark is it? Is it a mako? Like what's going on? And so there was a long time where we couldn't figure out what it was. It wasn't getting that close to the boat. And eventually it started to come closer. And it was a blue shark, which I was super excited about because for my thesis, the main species that we focused on is the blue shark. They're these really beautiful, they're like very slender, kind of iridescent blue sharks. They live mostly in the Indian Ocean. They are the most commonly caught species in bycatch. They have a pretty high reproductive rate, so they've been kind of able to handle the large scale fishing better than some other species.
Mm-hmm.
It came up to the boat, like you could see how blue it was. There may have been some throwing of anchovies into the water to feed it. And it hung out with the boat for maybe like an hour. It was just this really incredible moment because I had spent all this time just looking at all of this data about like dead blue sharks from like 50 years ago. And I finally got to see one in real life. And because they mostly live in the open ocean, it was like a very rare opportunity to actually see the species. I feel like most people don't actually get to see them ever. So that was super special. We were in the tropics and it was a fairly small individual. It was probably less than 2 meters long. Blue sharks are mostly a temperate species. They tend to hang out in the lower latitudes where it's cooler, but they do come up to the tropics to breed in the Indian Ocean. And so it was really special, like after having looked at all of this data on like dead sharks and how much sharks were suffering from fishing, to see one that was like early on in its life, like possibly going to breed for the first time, and to just like see the future for the species. It was really magical.
Oh, that is so cool. I love it. Magical moments in the ocean with blue sharks. How old are they when they start to reproduce?
I am not sure about that. I want to say maybe around like 6 to 8 years old.
Okay. And do you know how long they live?
I think they live around 20 years. I think in terms of like the open ocean sharks, they're a little bit on the low side of longevity. Because there are species like the short fin mako, they don't, in the Indian Ocean, they don't start to breed until they're like 20 years old and they live to be around 40.
Right. The reproductive age and then lifespan of sharks varies widely, but it's longer than most people realize.
Yes, yeah, definitely. I think they do like to kind of compare them to like the lions of the sea because they're very long-lived and it takes them a long time to reach sexual maturity, which is why it's such a problem when you start to fish out all of the mature ones.
Right. That makes sense. So at the end of each episode, I like to leave listeners a conservation ask to go forth into the world and do. What would you like listeners to take from your episode?
I have like a very short, like 2-minute ask and then kind of a more ongoing one. So my 2-minute one is to just like look up a video of a swordfish or a tuna because they're such beautiful, magnificent, impressive species. And like prior to when I started doing research adjacent to them, I like whenever I thought of tuna, I just think of like something in a can. So I think just like being able to appreciate these species for what they are is really powerful. And then my longer term ask is to just ask where your seafood comes from. Start interrogating that. I think like looking at aquaculture versus wild caught. We don't have time to get into that right now, but thinking about that kind of thing and just like asking at restaurants where the seafood comes from, because we really think that the way to curb illegal fishing is through transparency and knowing where your fish is coming from. Because without that, there's no way to know whether your seafood is coming from a boat that uses forced labor, a boat that is engaging in unscrupulous IUU practices. Transparency, we think, is how we're going to get there in terms of having sustainable fisheries. And the way to get to transparency is through people asking where their food is coming from. So start looking into that.
Yes. So that's the best way as individuals that we can help combat IUU fishing, is to just ask and know where the seafood's coming from.
Exactly.
Okay, I love it. I am that person at restaurants that asks. And the servers are always like, I don't know. I'm like, oh, okay. Can you find out?
Yeah, it's useful to know like what kind of gear, even just like what kind of gear was used to catch the fish is valuable information because they have such varying ecological impacts.
Yes, right. Yeah, if there's like a single hook and line, it's infinitely more sustainable than long lining or trolling. Yes.
Exactly.
Absolutely. Wonderful ask. That is something I advocate very heavily for. I love it.
Thank you.
Wonderful. So if listeners want to find you, connect with you, or learn more about you, your work, or Oceana, where's the best place to do that?
Probably Twitter. My handle is GEE__NMNE.
Perfect. I'll put a link to that in the show notes, along with everything else that we've kind of chatted about today. Emma, this was really fun chatting with you. Thank you so much for taking the time to be on the show today.
Yeah, thank you so much for having me.
Hey, one more thing. Do you want to dive more into the ocean and marine biology? Need a little guidance on ocean conservation? Head on over to marinebio.life/resources. We've got book recommendations, job posting pages, conference suggestions, and ocean-friendly products. All recommendations have been personally vetted by me, and I will continue to add to the collection as I come across cool things to share. Head on over to marinebio.life/resources to learn more. See you over there. Thank you for listening to today's show. I'd love to hear any insight you've gleaned. Leave a comment in the show notes or send me an email over at marinebio.life. If you enjoyed this episode, leave a review and of course, share with your friends. If you want more resources for ocean news, including conservation topics and careers, plus personal insight from me that I just don't share anywhere else, join me at marinebio.life and sign up for email updates. Keep after your dreams and making waves in your community. One person can make a difference. Thank you so much for listening, and I'll catch you next time on the So You Want to Be a Marine Biologist podcast.